Hi, everyone. Thank you for joining us at Best Practices for Themes and Styles. I'm Alan.
Hi, my name is Nick Butcher.
And we're going to be talking about some ways to think about themes and styles at a high level and how to apply those when you're designing themes and styles for your application. So first, let's start at a high level, the way that designers create mocks and the way that developers are interpreting them. So here's the latest iteration of the material design theme palette. So if you're not using material design components for Android yet, you may recognize primary as the color primary attribute from the material theme in the platform, primary variant as something like color primary dark. And when you get a mock from your designer, you may be doing a mental mapping of, oh, well, this is going to be my primary dark color in my theme. This is going to be the primary color. And embedding those directly in your theme. But it's important to make sure that your designer understands that there are these canonical attributes. So if you're getting a mock that just has a hex color specified, it can be helpful to maybe push back a little bit and say, let's call this the primary variant, or let's call this the primary color. And it's great that we have all of these predefined theme colors with meaningful names and meaningful contrast ratios that have to exist between foreground and background and additional colors in the material palette. Occasionally, you will get a brand new color that doesn't exist anywhere, and finding a name for this may be difficult. So here we have a purple color that's a little bit lighter than our primary variant, and it has contrast against white, so we're going to be displaying white text on top of it. If we want to come up with a name for this, we should find something that can generalize, but is self-documenting and captures these constraints, so that if we decide, well, we had a purple theme, now we need a blue theme, we can reuse the name of that color and reuse those constraints. So you could move from purple to blue very smoothly. So what are we going to call that? Well, over in the material palette, we have these on colors. On primary means this is a foreground color displayed on a primary background, and we ensure that it's going to meet certain accessibility-related contrast ratios. So you'll be able to read the foreground text color against the background. We have on secondary, which does the same thing for secondary. So if we're displaying something on that light blue color, it would be black text. If we're displaying something on this purple color, it would be white text. So we can use these to generate the new name for this lighter primary color. What should we call that? Well, we're going to use on primary, so that determines the foreground color protection. For background color protection, we want to make sure that it contrasts a little bit with primary, so we'll include both of these in the name. We can call it something like primary light, which seems incredibly straightforward, and it is. So you can tell your designer, hey, every time we're talking about this lighter version of our primary color, let's refer to that as primary light, and it's going to have these constraints for foreground colors and background color protection. So if your designer decides, well, in this next screen, we want it to be blue instead of purple, we can continue to use the same constraints on this color and use our semantically defined color name in our theme as well. All right, similarly, we provide common patterns for text appearances. So here you see on the left, we have headline, overline, body. These are semantically defined terms. They're meaningful names for where these appearances are going to be used. And that determines the pixel size, that determines the font weight, that can determine the font itself, and that's going to determine the color. On the right, we see what these values actually map to. So in this case, headline is going to be Roboto, and in fact, we're using Roboto throughout our entire app. However, if we decided that instead we wanted to use, let's say, Comic Sans, we could make our headline map to Comic Sans. We wouldn't have to go through and create a new style everywhere in our application, because we do have these names that imply how they're used. So always make sure to use meaningful names when you're extracting patterns from your mocks and applying those in your implementation. So learn the material design attributes. They're documented at material.io. Make sure your designers learn them too, and use this as a common language when you're looking at mocks and when you get something new that may have a random gray color in it that you're going to see throughout your mocks. Make sure it has a name that you can use over and over again, and if you happen to be implementing dark mode, for anybody who attended that talk earlier today, you'll know that this gray needs to turn into a light white because it needs contrast against a certain text color or a certain other background color. Use meaningful attribute names. They should be more or less self-documenting, Something like primary light is going to have more constraints than just, it looks sort of like the primary color, and the text color should be consistent with other primary. So go ahead and document these somewhere. Start a doc that you share, or start an internal site that you share with your designers to make sure you're always using a common language when talking about the components, the colors, the reusable textiles in your designs. You'll expand beyond what's available in material, I'm sure, but that's a good starting place to get a sense of how to name them and how to talk about them. And part of that is avoid hard-coding values. So when you get a mock that just says, this is the hex color 4A36EF, make sure that you push back on that and say, no, this isn't a hex color. This color has some sort of meaning, and we need to be able to smoothly transition from this hex color to a hex color with similar constraints. All right, so now Nick is going to talk a little bit more about what this means in implementation.
Thank you. Right, so we talked a lot about about supporting different semantically named values in your applications. And what that means on Android is essentially it can be implemented as theme attributes. And Alan said something really interesting there. He said, what happens if your design changes and all of a sudden instead of a purple theme, you have a blue theme? And how do you apply that? These semantic names protect you almost against these cases. And it's actually more widespread than you might realize. And I'm going to dig into that a little bit. So if you want to have areas of your app or screens which can support this kind of theming, there are different ways you could achieve this. One way might be that you just, say, define different styles. So in this one scenario, I'm going to set up a style to give it a certain appearance. We'll call that style 1. And in another scenario, I want it to look different, so I'll give it another style, style 2. The problem with this approach is that there's probably going to end up being a lot of duplication between style 1 and style 2. And there's now 2 places for you to maintain or bug fix or maybe refactor at some point. Using these semantical pointers to kind of describe what the appearance should be like, or in kind of coding terms, it's going to end up as a theme attribute, protects you against this. So while it might be more work to kind of like establish this language and to set up your styles to refer back to theme attributes, what it does is it actually ends up with just a single place, a single style, that will refer back to the theme attributes defined for a given theme. And the benefits of this is it's going to reduce that duplication. You don't end up with like 2 styles which are 80% the same, but have the potential to diverge in the future, which they will. It also localizes the modifications. So that means that if you need to change an attribute, you just go to that one place where it's defined and change that, rather than having to track it down where it's leaked out into all the variety of styles you have across your code base. It also has the benefit, I think, of consolidation. Like, how many times have you opened your colors XML file and found 50 different shades of very similar looking colors, and then you see a mock and it's not quite the same color, and you go, I don't know, I'll just create another color resource. Or is it just me that does that? It's kind of like protects you against this. You really, really, really want to kind of condense it down to this kind of small palette, which is used consistently throughout the application, so you have a nice look and feel. So to sum up, basically, this approach really, really helps you with the maintainability of your app. And so as such, I really urge you to prefer theme attributes where possible. By which I mean, if you find yourself writing code like this top line, so if you're saying the text color should be, this color resource, almost think of that as a code smell. Like, just think for a second, hang on, is there this layout? Is there a chance this might appear in a different theme? Could this be like included in like a different area of the application? And if so, should I instead be looking at this bottom form using the question mark * syntax, which is how you refer to these theme attributes? So we talked about the importance of having these kind of semantical pointers, but like, how might your theme vary? So hopefully everyone's familiar that you can set a theme directly on an activity. So in this example, 2 activities are using material components, which is a dark theme and then a light variant. Or perhaps you're using night mode, like Alan mentioned before, and is also talked about in the cost of a pixel talk earlier today. So this is a theme which will change between dark and light depending on the time of day. But what happens if you have a screen like this, which is from this is the Google I/O app, where we have largely similar content? So most of these list items are the same, but the design called for some of them to be light on dark and some to be dark on light. I mean, you can think of ways you might implement this as separate layouts, or perhaps setting text colors on bind or something like that. But both of those basically either leak out the sliding information beyond where you want it, or lead to like an explosion of more maintenance. Instead, what you probably want to do is look at applying themes at the view level rather than at the whole activity level. So the theme attribute was added, not theme attributes, the attribute Android theme was added in API 21, but also backported through Android X. So in this, you can set a theme on a view or a view group and apply a different theme to a subsection of your view hierarchy. So in these examples here, you might say you have a light theme and then apply a dark portion of it, or vice versa. You can do the same thing in code if need be by using the context theme wrapper, which takes an existing context which has a theme and overlays a style on top of it. I think it's really important to emphasize that fact that it is overlaid. That means that you have an existing theme, and any values from the theme you set on top of it are going to be applied on top. So you need to be a little bit conscious of this fact. You don't want to overlay a theme which supplies too many values. So for example, if I was using just material components.light and I overlaid material components.dark, they define a lot of the same attributes, and you might be relying on some of the attributes you set in the first theme to still be present, so you might overwrite too much. Conversely, you want to make sure the theme you are overwriting sets the things you need. So as such, you might want to take a look at these theme overlays, of which there are some in app-compat or material components, or create your own theme overlays extending from them just to theme the attributes that you want, such that when it's overlaid on top of the existing theme, you get the resulting kind of combination of themes. One thing to note as well is that while the context theme wrapper approach looks tantalizingly close to dynamic theming, it's not. By which I mean that you have to apply a theme which you've defined at compile time. You can't use this technique to, say, take some server-derived color values or whatever and create a dynamic theme. This is all about this kind of ahead-of-time thinking. Okay.
All right, so before you start setting a bunch of theme attributes, it's important to understand how those are applied throughout the platform. So we're going to do a whirlwind tour of the layers of indirection that occur between what you see on screen and what's defined by the platform and what you're setting in your application themes. So at any point in your application, it's good to have a background understanding that you can point at something on screen and understand all of the layers of indirection, all of the theme attributes and styles that were applied to render it this way on screen. So if we want to set this color for a single button, how would we do that? Well, let's dive into the way that this gets resolved at runtime. So we have button defined in layout XML. That gets inflated in the button class. If you watch the demystifying themes and styles talk that Chris Baines and I gave 2 years ago, you have a complete understanding of how this works. If you haven't watched that, go watch it. The important part is that the button style that you see here is pulled from the theme of the context in which the button is inflated. So relevant button style attribute here at the bottom of the screen. Next, where is that button style defined? It is defined on the material theme if we have not redefined it otherwise. So the default value there that you'll see in themesmaterial.xml is widget.material_button. Where do we find the definition for widget.material_button? Over in styles material. So we can see here the background is defined to be this button default material drawable. We'll also notice that right below that bordered ink button style, we have a colored bordered ink button style, which, if we've looked over the material spec, we realize is probably going to be a little bit closer because it provides a color in the button. So let's dive into the background that's used there to see what gets pulled from our theme and what we might be able to change. In the button colored material.xml, you'll notice the XML file names match up exactly with the drawable names, so there's an easy chain that you can follow. We have a shape. It's a rectangle. It is colored with a tint, which is our button colored background material. This gets applied to the white color of the shape, so it's got a solid white fill here. So let's dig into that tint and see what's going to be applied on top of that white color. It is our color accent. So this is a color state list. It is named button colored background material.xml, which is the exact name of the color that we were just looking at. Again, a very clear line of indirection. So where does this color accent come from? Well, because it's a theme attribute, it's going to come from whatever exists in our application theme. As I mentioned, that inherits from material, and if we haven't redefined color accent to be anything else, it will be the default teal. So here are all the levels of indirection that we've just looked at. Some of the important ones are if we want to change the style for all buttons that get inflated, that's our button style in the theme that we could set. The button style that we're getting by default is widget.material_button. we can change that to something else like button.colored in our theme if we wanted colored buttons everywhere. We can also change our colored accent, which is what gets loaded by the colored button style. So if we set that in our theme, that gets used everywhere. We'll see that color everywhere. But what we want to do is one button. So what would happen if we set button style on our activity theme? We would see colored buttons everywhere. We don't want to do that. What would happen if we set it in the style attribute on our button in XML? We would see it only on that single button, which is what we want. But now we're getting the default teal color from our theme. So how can we fix that? Well, what if we set color accent on our activity theme? Now we're getting that blue button, but we're also getting blue switches and blue everything else that inherits color accent. And if you just do a search over the platform XML files for color accent, you'll see it in a lot of places. So instead, we can set it we could try setting it in layout XML. You'll notice that this does absolutely nothing because it's a theme attribute, and you shouldn't try to set theme attributes directly in layout XML. Theme attributes get set in your theme. So what we'll actually do is create a theme overlay, as Nick was just talking about, that sets just that color and contains nothing else. We will apply that to the button using Android theme in layout XML, and we'll get what we wanted. So back to Nick for more implementation.
Cheers. So I said you should prefer theme attributes where you can. But to do so, you kind of need to know what is out there, what exists. And honestly, I don't have a great answer for this for you, other than looking through the attrs file of, this is from the Android platform, or from AppCompat, or material components. So looking through these, they're not that long. You can see what is available for you that you can reference rather than hard coding. Conversely, you can look at some of the common themes, like themes.material, and see which theme attributes they set. And as such, you are able to reference or override yourself. So it's good to kind of have a look through these and get an idea of what's out there. One note is that you might see that some theme attributes are kind of double defined. So the platform defines a Android color control highlight, and then AppCompat defines its own in order to provide backward compatible functionality. So which do you use? Basically, the answer is always, if there is one defined in the libraries like AppCompat or Material Components, prefer that, because they'll tend to set the platform one for you and then be available for backwards compatibility and so on. You can, of course, refer to these theme attributes in code using something like this, where we're doing obtain style attributes to get hold of it, and then using KTX's get color or throw to make it a little bit more convenient. So far, we've talked about using platform theme attributes, and you absolutely should. But you can also create your own, and you should do that as well to make your applications more themable. Let's walk through an example of what this looks like. So here from the Dev Summit application, we have two screens which display very similar layouts, a list of sessions in both the schedule and on a speaker details. They only differ in basically how far, some space of the left, the key line, essentially, that we wanted to align it to. One needs to leave room for the sticky header time things. So to accomplish this, we defined our own theme attribute. So here this is in our attrs file called session list keyline. And then in the different activity themes for those two screens, we can provide different dimension values for that keyline. And then we just have to have a single layout which references that, that theme attribute using the question mark attr syntax in order to vary it without having to create separate layouts which you then have to maintain, etc. Another place that theming comes in absolute massive handiness is theming drawables. So we looked at an example from the platform button about how from API 21 onwards, all platform drawables support tints and tint modes. So here we're applying the color button normal. You can also do this in vectors, where they support theme attributes both for tints as well as for fills and strokes. So you can use this not just from 21 onwards, but in the backwards compatibility library as well. And if you need to apply tints in a backwards compatible way to exist prior to 21, you can use drawable compat like this in order to set some tints on an existing drawable. Drawable compat also offers an override which lets you set a tint list, a color state list to be applied, which is something we have learned is to be extremely handy. So like the example we looked at before, you can define a single color state list which provides these different tints or colors for different states. So this example is taken from text primary. And one of the things I love about color state lists is some of the improvements that arrived in Marshmallow 23, which allowed you to separate out the color and an alpha component. Why this is great is because this really protects you against that explosion of like 20 different opacities of black you might have in your colors file. by actually separating out the kind of the color information from the alpha information allows you to define more specifically what you want. So here we're saying, say this is a light screen, so color foreground will be dark. You can say the text should be black, and it should have these different alphas, depending if it's enabled or disabled in these two examples here. So you don't have to define all these different combinations. You define specifically the semantically named things, like disabled alpha, primary content alpha, and foreground color separately, and then they get combined by the color state list at runtime. One thing to note is I've actually cheated here and changed the Android alpha to app alpha because app-compat backports this new function, new features added to color state list, but it requires you to use app alpha. One thing to note is that the alpha channel of the color and the alpha are combined, they're multiplied. So be careful, don't do this essentially. If you specify this is like, say, a 50% white text if you don't speak hex, and a 50% alpha, you'll end up with a 25% alpha white. So you probably want to refer to colors which have full alpha, and then only supply variable alphas via the alpha channel separately. And like I said, app-compat backports this, so use app-compat resources to inflate that in order to get this backwards compatible behavior, and then you can apply those to drawables. So overall, if you apply this theming, you can get to a state like this. So on the left, these look quite similar, but on the left we have the Google I/O app, which we forked to create the Android Dev Summit application. And to retheme it to fit in with the look and feel of this conference rather than I/O, this is basically the diff. Essentially, we just had to change a few of these semantically named colors. And if we go back, this ripples outwards to all the components. So the fab changes, the bottom nav changes, some of the tints on drawables changes, the star color changes. Like, think about if your product manager comes to you and says, hey, the company's had a rebrand, and we're changing all the colors. Wouldn't you rather just have a diff that looked like this, rather than trying to go through every layout XML or colors file and work out which color is which and where it's used, and then can I change this, and where is it going to affect? You really want to limit the changes to these semantic names. So as a kind of summary of this, really theme attribute all the things, essentially. Use them as this kind of protection. And you should probably push that kind of semantic system back upwards to your designers so that they're kind of giving you values that work with this. In your layout XMLs, prefer that theme attribute syntax, the question mark attra syntax, or be careful when you're not writing that, thinking, is this a smell? Should I be doing something else? And with your drawables, think about using tints, so to protect yourself against these changes down the line. Just think if all these those drawables had been pings instead, and I had to, we had a rebrand, am I going to have to completely generate all these pings again with a new color which is already baked into it? Ignore that, don't do that, use tints instead. Basically, if every time you use a PNG, think, should this be a PNG? Is this going to be usable or tintable later? Maybe prefer a vector. Do prefer vectors. Pretty much the only time you should be using PNGs is for 9 patches. So that's a summary. Protect yourself using semantic names and theme attributes, and have fun with themes and styles.